Okay, well, good afternoon, everyone. I hope you're all still in good health, and thank you for taking time to attend our Energy Talks and Drinks. Hopefully next month we'll be back at the Buccaneer in Delft with this Energy Talks and Drinks. At least we're trying to get it organized, and we have already taken some measures to receive visitors again. So really looking forward to that. Today we'll talk about minimizing environmental impact with low carbon transport solutions. Today's speakers are really pioneering in this field. We have three industry experts ready to share their expertise and innovation. We'll kick off today with Isabel Welton from GoodFuels. The program said it would be Bart Hellings be presenting, but he is indisposed, unfortunately. But we're very happy that Isabel can take over. Isabel is CCO at GoodFuels, a company active in the sustainable fuel market for shipping, amongst others. And one of the things they do is that they help ship operators and cargo owners to decarbonize their operations. Isabel, if you're ready, you can start.
Sure, thank you very much, Ashley, for this introduction. I will share my screen. So hopefully you will see it soon. Okay, so there is a small problem in my system settings to be able to share my screen. That means I have to leave the meeting and I will be back in 2 seconds because it needs to quit the system. Not sure, Ashley, we can also maybe start with another participant and then...
Let's do that. Yeah.
Yeah? Okay. Then I will leave and I will join, but you won't notice, and then I'll do the second one.
Okay, no problem. Okay. Well, David, are you ready?
Yeah, let's unmute myself. That's very important. Okay. Yeah, I'm ready.
Well, David is a supply chain analyst at SkyNRG. SkyNRG is a global market leader for SAF, known as sustainable aviation fuel, made from sustainable raw materials. And David will share some of SkyNRG's innovative initiatives with which they are supporting the sustainable growth of air travel.
Yes, let me check for 1 second if it works on my side. Let me see. Share. So, do you see a screen?
Yes.
Or...
Yeah.
Yeah, good.
Perfect.
So it works. Yeah. So thank you very much, Ashley. Yeah, pretty excited to present today. It's quite a unique experience, I must say, as I said before. That even presentations are done virtually these days. So yeah, as you mentioned today, I'm gonna tell you something about sustainable aviation fuel. So I'm gonna introduce you to the world of that. So some of you will think right now, well, that's funny because aviation is pretty sustainable at the moment due to the corona pandemic. So yeah, at least that's what of my friends asked me. And they say, well, that's pretty sustainable, right? So the short answer is that on the short term, yes, it is more sustainable, but on the long term, it's not. So let me see. Yeah, so it works. So what you can see here is the air traffic activity and how it's affected by the outbreak over a period of time in China. What strikes me most is that activity is already starting to rise, as you can see from left to right. And now 2 months later, it's already higher than on the right on 12th of April. In fact, it is forecasted that the air traffic activity will return to 2019 levels in 2023 and fully recover in 2024. So moreover, it is expected that due to the world's population and GDP growth, it will likely result in new record heights in air traffic activity by 2024 and 25. So yeah, in other words, yes, the aviation is affected on the short term, but it's here to stay on the long term. It is therefore up to us as a society to mitigate those risks of aviation industry which is mainly the carbon footprint. Before the COVID outbreak, it was generally known that aviation will continue to grow with 5% per year without timely action, and it will consume 20% of the global carbon budget in 2050. So it is not unlogical that society demands sustainable measures. Luckily, the aviation industry itself is aware of this, and they have set some ambitious goals to reduce this their carbon footprint. What you see here is a graph of this carbon footprint till 2050. Without any actions, this is where we will end up due to the 5% growth per year. Therefore, the aviation has agreed that from 2020 onwards, there will be a carbon neutral growth. But even a more aggressive, very ambitious goal is to reduce the carbon footprint with 50% by 2050 compared to 2030 levels. To do this, there are several solutions. The first is efficiency improvements, such as newer efficient aircraft, but also more efficient air routes. But this, however, will reduce the total emission but by 1.5%. It helps, but it's not enough to fully reach the 50% reduction goal. Therefore, it's very important that other solutions, such as sustainable aviation fuel and new technologies, are needed, such as electric flying and hydrogen flying or hybrid. However, although we as SkyNRG, we applaud these alternatives because we're in for the sustainability. We are also aware that it's not realistic that this will be available on a large commercial scale in the next 20 years. It is therefore that there's a large dependency on sustainable fuels to achieve these targets. And as you can see, it is expected that 300 million tons of sustainable aviation fuel will be needed in 2050 to reach those goals. So now I've been saying a lot about sustainable aviation fuel till now, but I think it's an important, since it's a very important topic, to know what is exactly sustainable aviation fuel. Well, to know what sustainable aviation fuel is to know its enemy, and that's fossil jet. Fossil jets, in its principle, is taking new hydrocarbons, so that's crude oil, and subtract that from Earth and emit new hydrocarbons into the atmosphere. Sustainable aviation fuel is actually the same, which means that it's a drop-in fuel, such as conventional air, but the fuel can be used in conventional aircraft. But with the only difference that the fuels are made from existing hydrocarbons, such as waste streams, like used cooking oil. These hydrocarbons are recycled, and because of this recycling, this results in an 85% reduction of CO2 emissions, 90% fine particles reduction, and 100% sulfur dioxide. So two things are important to mention here, is that the feedstock itself is different. Instead of crude oil, we use different sustainable feedstocks such as canola oil, use cooking oils, or even municipality waste. And the second thing is to remember is that the fuel itself is not different. It can be used as a drop-in fuel in conventional aircraft. So the aircraft themselves that are existing right now can be used. So SkyNRG has been for sustainable aviation fuel from its beginning, since the beginning of its existence 10 years ago, with its first commercial flight in 2009 with KLM. And as you can see, we have not been standing still. We have been doing a lot of projects and a lot of clients, so that's great. But I think it's, instead of to stand still, I think it's important for you to understand what we do as a company. Well, it's twofold. As you can see, on the short term, we fulfill the SAF demand, meaning that we are a one-stop shop, which means that we make it possible that airlines can buy SAF. But on the other hand, we also develop programs with airlines to reduce the premium of SAF. because at the moment SAF is more expensive than conventional jet fuel, and we want to make a parity with fossil jet fuel. So the premium has led that the price today has dropped to 2 to 3 times more expensive than conventional fuel, whereas 10 years ago it was 15 times more expensive. So we've been working on that to reduce the premium. But to reduce the premium, we have been doing something also on the long term, and that's the long-term activities that's creating the SAF demand. So on short term, we are fulfilling the SAF demand. That results that airlines can buy the fuel, but on the other hand, we also create. So we are committing ourselves to create new volumes of SAF. We do that by consultancy with our expertise projects, but more importantly also pilot projects to develop new technologies that turn resources, so new feedstocks or existing feedstocks, into fuel. We do that with our future fuel teams, which I'm part of it. But lastly, and that's the most left, that's the something that we are now deeply committed to, is to turn this business to a larger scale by developing commercial soft production facilities, which are called direct supply lines. And so actually building a refinery, but then for SAF. So in fact, our first facility is planned to come up online in 2023, which we're pretty proud of. In the DSL 01, we will turn regional waste oils into jet, but also byproducts such as bio-LPG and naphtha. This facility is pretty unique. It's first in its kind in Europe, as it's a commercial plant dedicated to producing 100,000 tons of jet fuel per year. However, we are aware that these waste streams, so the regional waste oils, are limited, and therefore we are continuing to focus with our future fuels teams and our whole team, whole SkyNRG, on other converting technologies, with the eventual goal to create more DSLs with different technologies and feedstocks to produce jet. So just to mention two of other projects, which I think it's nice to share with you. For example, we have been working now in Sweden. We are committed in focusing on turning black liquor. Black liquor is a byproduct of the craft pulping process into jet fuel. And as you can see, we are focusing for every DSL or every technology, we are looking at the region itself and what there's an abundance or something that's very unique for that region for feedstocks. And in this case, that's Sweden has the forest industry. Another project which makes me personally really excited because it's almost sounds like science fiction is turning air into fuels. With this technology, we can literally capture CO2 from the air and turn that into jet fuel. And we have been proving that it's possible for a pilot unit of 1,000 liters per day, together with Rotterdam Airport, Schiphol, and the company that developed the technology, Climeworks. So that's actually in a nutshell. These projects are just the tip of the iceberg of our sustainable initiatives. I would love to share more, but for now I think there's a lack of time. But please reach out if you would like to know more. I would love to share where I can. But for now, I'm happy to answer any burning questions. So thank you very much. I think maybe it will be nice to turn off the share screen just for 1 second. Yep.
Okay.
So am I visible, Ashley? Yeah.
Sorry?
Am I visible again?
No.
Yes, but we still see your desktop.
Yeah. Okay.
We can leave it like this for a moment.
Yeah. Yeah.
Let's go to some questions.
Yeah, sure.
why is 2030 used instead of 1990? Paris always uses 1990 as the starting point.
Sorry, can you repeat that? Oh, why is the 2020 used instead of 1990? Yeah. That's a fair question. I think that's comparing apples with pears. 2030 is something that the industry itself, Corsia, that's a different unit, which is related to the Paris Agreement, but as an entity in itself that made their own projections into the future.
Okay. Another question. What currently happens with used vegetable oils?
What currently happens with used vegetable oils? Yeah. So if you go some years before the bio industry, so it's important to mention that not only jet fuel is looking into used cooking oil, there's also the diesel industry. So that's the road transport is also looking to the used cooking oils. So that's also a market that uses it. But before, in that period, before that the industries use this to turn into fuels, they also used to dump the used cooking oils into landfills. So that was a devastating impact on the environment. Important. So that's what happened till before the bio industry. But now at the moment, it's important to mention that the road transport industry also uses used cooking oils. And Isabel is from GoodFuels, and that's a party that also is looking into that.
Okay. Let's do one last question before we go to Isabel. Looking at a question from Hans regarding the premium price, which is 2 to 3 times of the current price. Are there any efforts being done to get this type of fuel subsidized, similar to what's happening in wind?
Fair question. Yeah, so it's important to understand that this whole market of sustainable aviation fuel, if you leave it to the industry itself, a lot of things will happen. So we do need a mechanism such as subsidizing, but also blending mandates, which is the Netherlands at the moment is looking to. They're saying right now that they would love to, in 2025, to have a blending mandate of 14%. So those kind of mechanisms results that eventually the whole industry will start using sustainable aviation fuel, which eventually results in reducing the current price of 2 to 3 times the jet fuel. Just to mention, important things to mention is that the jet fuel industry, or the conventional jet fuel industry, is a very efficient industry till now. There are very large refineries with a very efficient downstream supply, and the sustainable aviation fuel at the moment is not. So to reduce that price premium, yes, we will need some help from the government, but more aggressive goals are needed to do that.
Okay, thank you, David. Let's save the questions that are still in the chat for in the breakout sessions. Yeah, let's go to Isabel. I hope I hope it's working right now.
Yeah, let me. I think it is working now. So.
Yes, something is happening.
Yeah.
Yeah.
Okay, that's good to hear. Thanks a lot, David, for your previous presentation. Indeed, there is some overlap in, for instance, the feedstocks that we work with. I think more or less the vision that we have when it comes to decarbonizing transport. And there is a strong link between GoodFuels and SkyNRG. The founder of GoodFuels, or GOODNRG as our holding is named, is the same founder as of SkyNRG. So in that sense, there is a lot of overlap, I think, in vision and mission, etc. Maybe to start with the mission statement of GOODNRG as a group, because what we do basically on behalf of GoodFuels and Good Shipping, as a GOODNRG group, we have a mission to accelerate the transition to fossil-free transport. And we do that by offering both a physical product, delivering fuels to transporters, but we also do that by providing a service to companies that do not have their own fleet, but for instance are responsible on the other hand side for emissions by transporting their products and goods. So on the one hand side we have GoodFuels. The mission of GoodFuels is to accelerate the transition to a fossil-free transport by co-developing and commercializing truly sustainable alternatives for fossil fuels. Basically, GoodFuels is really offering supplying physical products. And on the other hand side, we have the Good Shipping program with the same mission to accelerate the transition to a fossil-free transport. But we do that by empowering cargo owners to switch to a sustainable fuel and together change the industry. I will come back to that a bit later. Today, I will focus more on GoodFuels. And within GoodFuels, we also have different segments we focus on. So we focus on marine and we focus on road and rail. The role that GoodFuels has as a fuel supplier is not as simple as we would say as it is currently the case for fossil fuel suppliers. It's not that we get a call from a vessel to deliver some bunkers and then that's it. We really look together with our customers, with our partners, how we can facilitate them to make a business case for using a biofuel. As David already also said, biofuels are more expensive at the moment. It's also the case for shipping. It's also the case for road transport, especially with the super low fossil prices at the moment. It's quite challenging. But we look together with our partners on how to make a business case for using a more sustainable but more expensive fuel. So that means that we also act as a partner when it comes to tenders, public procurement. We look at mass balance systems that customers can use and also offer to their customers. So we really look at longer term collaborations with our customers. In this 10 minutes, I will really focus more on shipping. Because that was also requested. I think it's most interested also for the target group today, but it's also good for you to know that we also focus on land transport. So for shipping, there are quite some challenges. Just like aviation, shipping is an international industry, which was excluded from the Paris Agreement. And that means that shipping at the moment is an industry that does not have a target when it comes to carbon reduction. The IMO, the International Maritime Organization, has set some indicative targets for 2050. Yet in 2023, these targets will be re-evaluated whether or not they are realistic and if needed, adjusted. And as such, there is no restriction for the industry at this moment. So that means it really comes to national legislation or the responsibility of the ship owner itself to do something about their carbon footprint. And this year, beginning of 2020, there was important regulation implemented in the shipping industry regarding the sulfur cap. And we believe that now this regulation on sulfur has been implemented, which took quite some years for ship owners to prepare. There will now be more focus, and that is also really, really needed, because if you look at the graphs at the right, about all the other industries are reducing their footprint, shipping is expected to increase their footprint with 50% to up to 250% by 2050, if no regulation is set for the industry. And that means that by 2050, shipping can account for 17% of the global carbon emissions. At this moment, shipping is around 2 to 3%. And what you also can see in the left graph is that it is quite big. So GoodFuels really tries to decarbonize the shipping industry by offering biofuels. I must say with that biofuels we believe at this moment are the best solution. They can be used as a drop-in solution, so it does not mean, it means that the vessel does not need to adjust its engine settings or infrastructure or whatsoever. It can be treated in a similar way as the fossil bunkers. And here you see the rationale for choosing biofuels at this moment as the most feasible option. The greenhouse gas reduction can be reduced, the greenhouse gas emissions can be reduced by 50 up to 90%, and the feedstocks and the biofuels that GoodFuels works with are between 80 and 90%. Other examples are, for instance, speed optimization is also a solution which is typically used, which was really the result of the last economic crisis, whereby you saw that a lot of container vessels, for instance, were implementing slow steaming, so they reduced their speed. That requires less fuel consumption, and that also enables vessel owners to reduce their greenhouse gas emissions. Yet, as soon as the economy attracts again, you see that the reverse effect occurs. And another example is vessel size. So you see now that there are already container vessels. I think it was in the news yesterday that one of the biggest container vessels in the world was calling port in Rotterdam. It carried up to 24,000 containers, which is more or less equal to 4 football fields in a row. But also for vessel size, we are reaching more or less our limits there. And if you look overall, biofuels have the biggest potential to reduce greenhouse gas emissions, as you can see here, among all the other alternatives. GoodFuels is offering different products, and I don't want to bother you with all the technical requirements of this fuel, but I think it's important to see here that we do 2 things. We offer different type of biofuels, but we offer blends as well. And offering blends is often used to make the step from both commercial as well as technical point of view a bit less challenging, I would say. This slide is also important to see the last column, the price. So we have biofuels which are significantly more expensive, yet we also have biofuels which are quite price competitive already. And I think especially when it comes to big vessel operators who are bunkering thousands of tons every month, this is super important that there is, in terms of commercial attractiveness, biofuels are becoming more of an option for them. So you see in our portfolio, it's really biofuels at the moment, yet we also focus on other solutions on the longer term. But before I go into that, I want to provide you with some examples in which we are active, the segments. So first I start with dredging and offshore. I already mentioned at the beginning that tenders is an example on which we are quite active. So we help our customers to win tenders. For instance, if there's a target or a requirement on carbon reduction, they can use a drop-in biofuel in order to fulfill that requirement. And very often a shipping company or client gets rewarded with a discount in the tender for that. So that means that they are more likely to win the tender. Jumbo is also a very nice example with a customer with whom we started the first deliveries last year. And actually the first delivery was very nice because Jumbo used biofuels for a decommissioning project. And symbolically, of course, that is great because it means that a fossil platform is being decommissioned by a vessel using biofuels. So that's the energy transition to the fullest, I think. Other customers are, for instance, port services and governments. So, of course, a lot of players in the ports have a very important role when it comes to providing the right example. So we have the Dutch pilots, we have the port fleets running on biofuels. And we also have government-related organizations. Think about the Navy or the Dutch Coast Guard. And these are especially the Navy, they have a very interesting reason to use biofuels, and that is more the strategic ambition that they have to become less dependent on fossil fuels. So it's more a political rationale, but not less important, I think. And then the Good Shipping Program, I already told a bit about at the beginning. It means that the Good Shipping Program is offering the service of decarbonization. And typical customers are IKEA, Dopper, Tony Chocoloni, Mail Unie. These are customers that are willing to decarbonize their ocean freight. They pay basically for the premium of the biofuels, which enables us to deliver the biofuels at fossil parity to the ship owners. So it's a win-win situation. The cargo owner gets back the control on their own emissions, whereas previously it was really outside of their own scope of influence. And the ship owner gets the biofuels at fossil parity. So from a commercial point of view, there's no reason why they wouldn't want to do it. And then I think this is one of my last slides, future product offerings. Basically, GoodFuels, we're now offering a biofuel. I already mentioned it a few times, but we look on the longer term at supplying renewable alternatives as well. But it's always renewable alternatives to the fossil fuel standard. So you see now a lot of LNG in the market coming up. LNG is a very good product for local emissions. So in that sense, it's a very clean product. However, it's a product made from natural gas, so it's still a fossil product in that sense. So in terms of CO2 reduction, the impact is limited to no. But if you produce LNG, for instance, from not natural gas but a biogas, then you also have the CO2 reduction. So that would be an interesting alternative on the longer term. But also other alternatives, biomethanol, bioethanol, renewable hydrogen are already alternatives and solutions we are actively looking into. For us, the most important reason whether or not to offer these solutions is the commercial viability in the market. And then in terms of feedstocks, now we mainly work with waste oils. So in terms of sustainability, it should really be waste streams that cannot be used for anything else. But on the longer term, we also look into other feedstocks that can be, for instance, solid biomass instead of liquid biomass only, lignin-based solutions, but also plastic and waste-based. And in terms of sustainability, you could say it's then no longer a bio feedstock that you use. But if you use, for instance, plastics which cannot be recycled anymore, so the only option would be to just burn it or use it for landfill, then it's better to convert the waste into a biofuel, because at least you get transportation and energy in return. So in that sense, we always work via the cascade principle, meaning that we always look for a feedstock, a waste stream for the highest quality application possible. If that means that at a certain moment it would be interesting to produce a or a renewable fuel out of a plastic bottle, for instance, this should be a continuous evaluation whether or not the bottle can be recycled, for instance. And that was my presentation for now. So thank you all for listening. And probably there will be some questions, so happy to answer these.
Thank you, Isabel, for your presentation. Very clear, in my opinion. We have two questions, and the first was about will hydrogen be an alternative? But I think it's already quite described in one of your last slides. Yeah. Another question, all the other industries are also looking at these residual materials for heating purposes. Will there be enough for the production of biofuels?
Yeah, so that is a very good question, because when it comes to competition about feedstock, that is something indeed which is very often addressed. And to give you an idea, there is an overview of different studies when it comes to the availability of biomass as a feedstock to produce, for instance, biofuels or other energy sources from. And if you look at that study, then it says that 15 out of 16 studies confirm that there's enough biomass waste streams available to fulfill the need of the whole transport sector. And it is important to emphasize the whole transport sector, because what we really believe as GoodFuels is that, for instance, for passenger cars or for other means of transportation, but also smaller vessels, these can be, for instance, electrified, or the options for other sustainable alternatives are already there. So that means that biofuels should only be allocated to these transport segments who need it the most. That is, in this case, on the longer term, that is aviation and shipping. So when it comes to indeed sustainable feedstocks, yes, you can also use them to produce energy out of it, but it's much better, I think, to produce energy in other ways. It's much more difficult to have a vessel running on solar cells or wind energy than it is then to produce energy, because you have a lot more flexibility when it comes to producing energy than when you have a vessel running, sailing in the middle of the ocean, being dependent on solar energy, for instance.
Okay, thank you. The last blend was oil-based, expensive and no carbon. Can you please explain?
The last blend was oil-based, expensive and no carbon. Not sure, sorry, Theo, maybe you can clarify this question. I'm not sure if I fully
understand. Can you please unmute yourself, Theo? Maybe I can unmute you.
Yeah, I'm now unmuted, I guess.
Yes.
Yeah. And you showed a list of blends and pure biofuels.
Yeah.
And the last one, it was MDG or MDO?
Yeah, MD1 blends. Yeah.
It was oil-based and it was very expensive, and still it was sustainable. I didn't understand that.
Yeah, so it's basically a blend between a very expensive biofuel with a fossil component. So it's a blend between these two. And of course, it really depends on the blend ratio that you apply. If you apply higher blends, higher bio percentages in the blend, then it is more expensive. But due to the fact that this biofuel component is already so expensive, even if you blend it, there will still be a premium. To give you an idea, at this moment, marine gas oil prices are around €300 per cubic meters. If the price for the bio component is much more expensive, then even if you have a low blend of biofuels, there will already be a premium. And what I already mentioned, especially due to the fact that the fossil fuel prices are super low at this moment, for some of the products, for some of the biofuel products which are not linked to the fossil based prices at all, there is quite a significant premium at the moment.
Okay. I would like to continue to Rick, because we're otherwise we're going getting short in time. Please reserve some questions for afterwards. If not everything was answered right now. Isabel, thank you very much for your presentation. And let's go to Rick.
Yeah.
Last but not least. Rick is logged in with two accounts because he had some difficulties with the microphone on his laptop. So yeah, he is there, but not directly visible. But no problem. Rick is from Hardt Hyperloop. He is there the project lead, and Hardt is one of our in-house scale-ups, one of the Buccaneers from almost the beginning. And since the beginning, a lot has happened. And Rick will update us now about Hardt's developments in both cargo and public transport, looking into a recent published concept study, and of course the announcement that the province of Groningen will be the host for the European Hyperloop Center. Okay, Rick?
Yes, great. Thank you very much, and thank you for giving me the opportunity to present Hardt Hyperloop here. Let me first put on the presentation. So that's great. If I'm correct, everything is working now. And thanks again for attending this session. My name is Rick, and I'm working at Hardt not since the beginning of the company, but only since February of this year. And it has been one of the most dynamic periods in my life, but I think that's applicable for everyone. I'm one of the project leads here, and I work for the cargo loop that I will tell you later on a little bit more. And at first, I would like to take you along with the vision that we have as Hardt Hyperloop, which is a world where distance does not matter. Well, it's a very nice vision, of course, but it always has to come with a mission, which is also depicted on the screen. I'm quite happy to tell you more about what Hardt Hyperloop is doing. But before we are going to our current technology, I think it's pretty nice to take you for a small travel through the history of mankind, because already for as long as we know, we see that human mankind is always going hand in hand with migration. And it's not always the very big migrations as the first one that we saw coming all the way from Africa, spreading over the continents, but also, for example, going to the moon. Well, I think that's like another type of migration as the first one, for example, but it is something that it's really related to mankind. And especially if you look to the last 100 years, you see that traveling has become part of what we do on a daily basis. And we must also admit that the current crisis, which is going on, is really having a big impact on our daily travel patterns. That's what we see especially. And I was also quite happy that David presented his expectations on what the prospects for aviation. That, well, the COVID crisis is having very deep impact on our daily pattern that we do. But we also strongly believe that within a few years we can will restore to the way we traveled before. And up till now, we have been traveling more than ever before. It took us about 4,000 years to get to 1 billion people on this planet, but it only took us a few hundred years to get to the 7 billion people on this planet that we are now on at this very moment. And these 7 billion people, they travel a lot. So we see that our city transport systems are completely clogged. The highway is very dense, and also the huge amount of planes in the air is really breaking it up. And what do we do when we see that the highway is clogged? Well, luckily not really in the Netherlands, but as we all know, for example, in America, we just built a next lane to it, giving you these awful pictures, if you would ask me, for example. Not only on highway perspective, but also if you take a close look into our railway systems, often systems that already are functioning on techniques that are 50, 60, 70 years old. And if something breaks down, a minor component, the whole system can come to a full stop, really causing big problems in rush hours, people getting stuck at stations. And also, if we take a look to newer modes of transportation, aviation, we see that the aviation industry is really growing. I think it's about doubling every 15 years. That's at least what we have seen until so far. And we're specifically not against aviation, but we believe that our mode of transportation, the Hyperloop, can exist really good next to that. So that brings me to the question, what is Hyperloop and how are we going to do that? We believe that Hyperloop is a cheap to build transportation system that is having a higher speed than railway. It is definitely more energy efficient than when you take a plane. And it is having an overall higher system capacity if you compare it to other modes of transportation for longer distances. The Hyperloop technology is about 3 parts. We are in a low pressure environment, making sure that we don't have much resistance when it comes to air resistance in the tube itself. We use magnetic levitation to reduce the amount of resistance on the rail that we travel on. And we are shielded from the outside environment, means that we don't get interference with storms, with weather, with rain, etc. The Hyperloop technology is visualized in this picture. What we see here is that the vehicles are lifted with magnets that are attached to the vehicles and go up to the rails. And the motor of the vehicle is actually on the rails itself. So the motor in the tube makes sure that the vehicle will move. It is keeping in place by 2 guidance rails on the left and the right side that we can see, keeping the vehicle in place, which is done automatically by the vehicle. And we have a patent switch technology, making sure that these side guide beams also allow the vehicle to switch without any movable components. And that's really new in Hyperloop industry. So if we combine the technologies as I was explaining before, we can travel up to the 1,000 kilometers that we promised that we will do. Well, that's definitely not something that's going to happen tomorrow, because a lot of things needs to be done before we are able to do that. Most important part is, of course, the technology that we have to prove, and we are happy that we've proven our technology up to the levitation and the switch. Only the high speed is there yet to be tested, and that's what we are going to use our European High Speed Center in Groningen for. The construction of that will start this summer. We are going to be needing a regulatory framework, so to say a set of norms and guidelines that allow us to operate Hyperloop, or us or any other Hyperloop party in general, a government or who is going to operate it. We need the public adoption, very important. That's something you always see when new transportation modes or new things happens in general. Because if you don't take your stakeholders with you, well, they probably will be against what you're doing. And of course, we have to develop the routes that we are going to travel on first. And this is basically a trade-off between either a good business case and, of course, the techniques and the pilots that we can also prove on this route. We believe that if we take a look to the current modes of transportations over the longer distances, it is not really a feasible option to keep on only working with aviation or railway industry, because if you look to the amount of CO2 that is emission by airplanes, well, we believe that it will be higher than the promises of Paris. I'm quite happy that actually I've just understood from the previous presentation that perhaps there is a solution in that. But if you take a look, for example, to the railway industry and the amount of money that is going to be invested in that in the upcoming 10 years, that's such a huge amount of money, and we really believe that can be done cheaper, all combined in the Hyperloop technology, which is then basically combining the both of the best of both worlds, if you would ask me. So what would it look like if it wasn't to us? We say that we can build a European Hyperloop network for about 14 billion annual profit on an annual basis, and reducing a significant amount of CO2 emission. We believe in that because our technology is mainly based on electronic propulsion. And on the other hand, to be honest, we also know that our construction and the materials and the stuff that we use will also produce a lot of CO2. For example, the steel that we're going to be needing for the tubes. So that's why we're also looking into more sustainable tube options, for example, some fiberglass or anything we're open to investigate to see if we can reduce on that as well. In order to get to that full network, we believe that it's very important to start with a small pilot, because, well, obviously the European Hyperloop network will not be there at once. So that's why we're really scaling down to a corridor or to many corridors that we're focusing on now. And at first to start with a pilot study that we are currently working on right now. So basically 3 things will come together in that pilot study. That's the product development. So after Groningen, we don't hope, we are sure we reach TRL 7. The standardization and regulation. So that's really an important collaboration with the national government, but also the institutes that make sure that Hyperloop transportation is going to be done in a safe and proper manner. And of course, the market developments, because if you have a nice tube from A to B, but nothing to transport in it, then, well, you didn't choose the right pilot route, I would say. If we look worldwide, it's quite interesting to see that we're not the only one working on Hyperloop, giving us the self-verzekerdheid assurance that we're not working on something that is basically non-existing or just a boy's dream. We are quite happy to see that so many other companies are also working together to make sure that this technique will succeed. Something that we are really focusing on, and that's really important to us, is that we set a European standard. We have chosen our own technology, as of course, because we are hard to be the European standard, but that's also due to the fact that we are the most advanced when it comes to Hyperloop technology in Europe. But the most important reason that we do this is that we don't want to have what we see, for example, in the railway transportation, that if you cross a border of a land between 2 member states of the European Union, you've got different signaling system, different overhead wirings, different, well, gauges even, what we see. So that's something we definitely want to avoid. So therefore we take a close collaboration with our European competitors. That's very, very important to us. How we're going to do that? We have a very fancy roadmap, like everybody else is having, in which the passenger scale systems have been completely tested. So that's our test facility in Delft. You've probably seen that on the news last summer. We have tested everything there. So we tested the switches, the low air environment, the vehicle, the propulsion system. The only thing we didn't test in there is the high speed. So that's what we're gonna need the European high speed test facility for, which can also be used, by the way, and that's very nice to mention, by the competitors that want to test their hybrid technology as well. Is start to work on the commercial cargo route. So we have the Hyperloop technology that we split, and this is something new that you will be hearing on more within a short time from now. We will be having the cargo loop technology that will expand into a European-wide cargo loop network. And as soon as we have a stable and proven technology on the cargo route, we will also start developing the passenger route, and then the high-speed passenger Hyperloop network that I was discussing before. So we dive a little bit more into the cargo loop because that's my project. The cargo loop is a type of Hyperloop, but then only in a somewhat smaller tube using the same technology as Hyperloop is doing. But then instead of transporting people, it will be transporting goods. Not every type of good is going to be suitable for the cargo loop. We don't want to transport goods like grain or oil or whatever. So the quite a cheap type of transport, but we're really focusing on the time sensitive and perishable cargoes, type of cargoes, for example, also e-commerce. So the market in which you order something before 5 o'clock and want to have it the next day is causing huge pressure on the current logistic systems, and that's typically a market we want to take a look into. So we're currently designing this cargo loop system. The specifications of the system are here visible on the screen, and currently we're working really hard to make this happen. And therefore, the test center in Groningen is also key to let it succeed. We have had many successes so far that I'm really, really proud of, because it was mainly due to the team that have been working before I joined the company. So it's a big applause to them. And then there's of course many challenges that we will be facing in the upcoming months and years as well to make this very nice dream coming true. But we're very confident in making that happening. So, and that's why we say that the sustainable connected world will start with the cargo loop. And that was my last slide.
Okay, thank you, Rick. Time for some questions. What is the energy usage per traveler a kilometer compared to trains or planes?
I don't know the answer by heart because I'm mostly working on the cargo loop perspective, and I have a colleague currently working on the figures for the kilometers. So the next question then perhaps could be, what would it be for cargo? And then I could use the same answer. I don't know it by heart, so I should look it up.
Okay. We can look it up for you, Koen. How much research has Hardt done directed towards the feasibility of the large-scale system and infrastructure? It seems the focus lies on showing small-scale prototypes working.
That's the last question. So that's something I've been working on as well, and I know that my colleagues did as well. We basically have two main approaches. One of the approaches is on the techniques to make sure that the vehicle is levitated and can use all the technical stuff. That it's of course the most important, because otherwise we don't have Hyperloop. But we also have the business team, and the business team is having just one solely purpose, and that is making sure that there are feasible routes, networks, business cases there to prove that the Hyperloop technology, as it is designed at the engineering office now, is also making sense in terms of routes and connections and hubs and stuff. And I don't think I'm really allowed to tell you already, but pretty soon from now we will have a release together with Schiphol in which we present what a European network could look like if we collaborate with the airports, for example. So that's basically going to give a very nice answer to your question, Leonard.
Okay, thanks. Last question. What will be the expected costs for using the Hyperloop? Will it be able to compete with airplanes or trains?
Yeah, that's quite a difficult question because we're not selling tickets yet for the Hyperloop, the passenger loop, of course. Well, some of the competitors, by the way, are already doing that. I think that's pretty cool from a startup perspective. I'm not really sure if if you could answer the question, given the fact that there are so many structures to price a plane ticket or a train ticket or a Hyperloop ticket, because if you look to the price that a passenger now pays per kilometer in a train, it's heavily subsidized with governmental money, and it also quite depends on the land you're traveling in, the situation you're in. For example, in Germany and France, there are many regulations in which if you're a student, if you're older, you get huge discounts on your transport, or if you're a normal traveler. We see that less in the Netherlands. Of course, we have discounts for elderly people and for students, but that's mainly basically it. So I wouldn't really dare to compare ticket prices from one mode to another mode. But what we have proven in our business cases, and that's something we have been working on to make sure that Hyperloop is a commercially viable option, is seeing, okay, what does the operation of a train system cost compared to the operation of an airline system between A and B, and the operation of a Hyperloop system, including all, well, CAPEX and OPEX, basically. So we've been comparing that.
Okay. Thank you. And if there are no other questions, I would like to suggest we move to some breakout rooms if there's if there's interest in. Otherwise, we can stay here in the main room, depending on how much participants will stay. Yeah, I would just suggest to put your camera on and unmute yourself to have a conversation or maybe even discussion. Yeah, let's see how that will work out. So feel free to join.